Hello, I'm Agustin Aditya Pratama. Nice to meet you. And in this video, we are going to talk about the definition and some properties of complex conjugate in complex numbers. Okay, let's begin with the definition of complex conjugate. For g is equal to a plus bi, we define the conjugate is to be g bar is equal to a minus bi. Then, we have a geometric interpretation of complex number, that is, fg6 is the real part of complex numbers and ordinate y is the imaginary part of complex number. If we have g is equal to 3 plus 3i, we get the conjugate to be g bar is equal to 3 minus 3i. Let's take a different one. We have v is equal to negative 2 minus 4i, and we get the conjugate is v bar is equal to negative 2 plus 4i. So, number and its conjugate are always mirror image with respect to the real axis. Now, the properties of complex conjugate. If we take the conjugate of g plus or minus v is equal to the conjugate of g plus or minus the conjugate of v. Then if we take a product and then take the conjugate is equal to the product of the conjugate. Then if we take a number and add it to its conjugate, what do you get? Let's think about it. Let g is equal to a plus bi and g bar is equal to a minus bi. Then we get g plus g bar like this. So plus bi and minus bi cancel out. So we get 2 times the real part of g. So what if we take g minus g bar? Let g is equal to a plus bi and g bar is equal to a minus bi. Then we get g minus g bar like this. What do you think? Right. The real part will cancel out now. That is a of g minus a of g bar. Then we get 2 times in the imaginary part of g times I. Then g is equal to its conjugate if and only if. Let g is equal to a plus bi and g bar is equal to a minus bi. When a plus bi is equal to a minus bi, so it has to be a real number. Okay, remember that the conjugate is a mirror image, so the number can be the same as conjugate, only if to start with the real axis if it's a real number. So g is equal to g bar if and only if the imaginary part of g is 0. Then g times its conjugate is always greater than or equal to 0, and g times its conjugate is equal to 0 if and only if g is equal to 0 is the complex 0. I think that's all about the definition and some properties of complex conjugate. Thank you.